The final portion of 7.3 talks about our side similarity. That's going to allow us to determine whether two shapes are similar, but now we don't have to worry about any angles. Okay, we've had angle where we had to know two angles congruent to two angles. We had known side where we had to have an included angle congruent to an included angle. But now side similarity, we don't need to know anything about angles. And basically what it says is if all sides of two triangles are in proportion, then the triangles are similar. Okay, so you can compare three sides to one another, corresponding sides in another triangle. Then they all reduce to the same value, then they are similar to one another. It means the sides are proportional. Therefore, the angles will be congruent, be a conclusion of this. What we talked about on, I think it was Friday, might have been Thursday, when we did side angle side, was like the smallest side had to be compared to the smallest side. If they're going to be similar, and we talked about how, I think I showed you like an enlargement. Okay, what I was making here was this. I'm taking this shape here, okay, this triangle in the first quadrant, and I dilated it, okay, rotated the dilation, and I reflected the dilation. So there's a lot of different kind of transformations that are occurring to this thing to make it kind of turn into this image over here. Okay, and my argument is if I want to determine whether these two things are similar or not, okay, I have to be able to compare, because I know nothing about the angles, but I do know what the blue lengths are, what the red lengths are, what the green lengths are, okay? What I have to be able to do is determine are all these segments, and when I match them to corresponding parts, are they in the same ratio as one another? And the argument is if these are just dilations of one another, and that's all similarity is that one shape is a dilation of another. Now there could be reflections and rotations in play as well, but the similarity feature is simply talking about a dilation. Then I got to make sure that I understand that if this blue segment, you guys agree that this blue segment looks like the smallest one in this shape on the right here? Yeah. Okay. Well, if I dilate that shape to something much bigger, okay, does it make sense that this blue segment is still the smallest one in this enlarged shape? That kind of makes sense? Because if that one grew to maybe being the biggest segment in this bigger shape, the dilated shape, then it would not be a direct dilation of this. Okay, we would change angles and all that kind of stuff. It'd be a problem. So what we're looking for, and when we're comparing these, and not too many textbooks will state this. They will actually make you run through all possible comparisons. But if we can recognize that the only way that these are going to be similar is if the smallest side compares to the smallest side, what would be the largest side compares to the largest side, and then the middle side to the middle side. If they all give me the same ratio, then we should be okay. So what I'm going to do here is I'm going to take the smallest side, which is AC, and I'm going to divide it by the biggest, or sorry, the smallest side, or so blue side divided by blue side. So it's A triple prime, C triple prime, and get a number 0.0044. Okay. If I then take the green side over here, which is BC, so small green side, BC, divided by the bigger shapes, green side, B triple prime, C triple prime, okay? If these are similar, when I hit enter, I should see this 0.0044 number show up again, okay? And let's see here. So something's amiss. I'm not going to go back. They're, for our purposes, they were, well, now I'm intrigued. First Wednesday of the month. One, 2, 7, 3, triple prime. Let's do it this way. Let's go. So if we go, so segment A is this length right here. So this would be the green, smaller green segment. Let's see if we can divide that by A triple prime, which would be this bigger green segment. See what number that gives us, and it gives us 0.27. Let's get rid of that number, get rid of that number. So green compared to green is 0.27. Let's go red compared to red. So we see when I highlight that C, it's referring to that one, and when I go C triple prime, so let's go C divided by C triple prime. Enter. And let's see, did that give us the same 0.27 number? Does that make sense? So green to green gave me 0.27, red to red gave me 0.27. Now if we go blue to blue, so the blue one would be B. So B compared to B triple prime through division should give me the same 0.27. Does that kind of make sense, everybody? Okay. So because I get that same, now 0.27 as a ratio, close to like 27 over 100, but it's going to be the same ratio for each of these three corresponding parts. So what that tells me is that these shapes are indeed similar, meaning if I were to find the angle of all of these, from the measure of all of these angles here, should be a way for me to do it quicker. If I look at that angle, 133. So come down here, look at the corresponding angle between the green and the blue. Is it the same 133? Okay. If we look at between blue and red, it's 30.692. Between the blue and the red down here, you see it's the same 30.692, right? So then that means that the angle that we haven't talked about between the green and the red, that angle right there at B prime, is going to be the same as the angle of B because of the third angle theorem. Okay. So what I'm trying to get at here is that when you are being asked to determine whether two triangles are similar and all you know is side lengths, is that you always compare smallest side to smallest side, largest side to largest side, middle to middle, because there's no other way that they could be proportional, but having like middle compared to largest and smallest compared to middle or something like that. Does that kind of make sense? Okay. Has to be small to small, large to large, middle to middle. And that's all the side similarity is referencing. So in regards to your homework assignment, you guys said, somebody said that the last couple questions were throwing them a curveball. So let's look at those real quick. And we can talk about any of these. We got time to talk about any of these homework assignments that or questions that you guys want to talk about. So, okay, this one is, were they all talking about? Okay, so 19, let's go to 17. Okay, so 17 says for the pair of similar triangles shown to the right, find the value of x. Okay. So as we look at this, and I think it's a good practice, even though they don't put them in here, for us to label some points here. It will make your life so much easier. So I'm going to call this point up here A. Just call this one B, C, D, and E. Okay, and right now, I know angle A and angle E are congruent. So if I were to name these triangles, I would say angle A and angle E need to match up when I make a similarity statement. Okay? Do you know this angle here and that angle there are also congruent? Okay, because they're vertical, right? So I'm going to go A to C and E to C. And then obviously in that top triangle, I'd have to finish at B. And here I have to finish at D. So what this is going to allow me to do is make sure that I create the correct comparison, whether I compare F or 5x to 9 or I compare 5x to x. And that's not always going to be extremely obvious, okay? So once I make this, I can go AC to EC. AC to EC, just like CB to CD, just like AB compares to ED, okay? And now I'm just going to go plug in the things that I know. Do I know AC? It's 5x. Do I know EC? It was 9. So in this case, I do compare 5x with 9. Okay. CB, 80. And then CD is our x. Okay. So when we cross multiply, we get 5x squared equals, I'm going to write it as 80 times 9. If you want to write it as 720, you could. But what do I do when it's x squared like this? Okay. Normally, I would set it equal to 0. But and the ones we've seen that have said that is because we've had an x to the first term. Okay, so you want to divide by that 5? So I'm going to divide both sides by 5. And this is why I didn't make that 720, because I don't like to do multiplication and then the next step know that I got to undo it with division, right? I think we know that we can take that 80 and that 5, and that's going to give me 16. Okay. So now I've got x squared equals 16 times 9. And now some of you might say, well, I'm going to multiply that 16 times 9 and write that as a composite number. You can, it's fine. But thinking ahead and knowing what we're supposed to do next, I'm not going to do that. Okay? Because right now it says x squared equals 16 times 9, right? If we have something that has, like something that is like ax squared plus bx plus c equals 0. So an example of that would be like 5x squared plus 3x plus 10 equals 0. That one we would factor. Okay? And the reason we would factor that is because we have an x squared. That tells us the factor. But the reason we're going to use this technique is because we have an x to the first as well. Okay? And that's where we use the product and sum stuff where two numbers that multiply together give me 10, add to give me 3, or whatever. Okay, whatever may be the case. But in our problem right now, do we have an x to the first? No. So we can take the square root right away. We can actually use the inverse operation, take square root of both sides. And the reason I didn't multiply things out is because when I take the square root of 16 times 9, the square root of a product can be rewritten as the product of square roots. I can do that. So 16 times 9 underneath can be broken up this way. Does that make sense to everybody? What's the square root of 16? 4. What's the square root of 9? 3. What's 4 times 3? 12. Okay? Now, if I was a person that just said, okay, I'm going to blindly approach this, I get x squared, it was really big. I get x squared is equal to 16 times 9. Okay, that turns into 144. And now take square root of both sides. Do I still get 12? Yeah. Okay. But eventually seeing relationships like this and knowing, okay, I'm gonna be inefficient with multiplying and then taking square roots. Or I'm gonna be inefficient with multiplying and then dividing by 5. Always think 1 step, 2 steps ahead. You can save yourself a lot of time. Did you guys work a lot with square roots last year? No. You remember? No? You know what square root is? So if I say like square root of 7, you know what that means? Good, okay. So I'm going to take, and the reason I'm talking about this is my Algebra 2 class that I teach. We're doing it, and it seems as though they've never seen them before, okay? What? I have no idea. Was that your computer?
No.
You're lying? Sounded like it was coming out of my projector. All right, so if I've got, so like Lily said, if I've got square root of 7, it's that number right there. Okay, so 2.6457513111, that's an irrational number, meaning it goes on forever, never ends, never terminates. Okay, it's like pi. We've got an infinite number of irrational numbers. Okay, all your radicals are like that unless it's like radical 4, which turns into 2. Okay, which terminates. Okay, but every other, as long as it's not a perfect square, all your square roots are irrational numbers. We can't write them, like I can't write that number in its entirety without cutting it off somewhere, right? Does that make sense? And once I cut it off, it's no longer in its entirety. So by writing the decimal version, I will never get a number that is equivalent to radical 7. Okay? But what this means, now, we got enough decimal places here to kind of validate this or show this with Desmos. But what it means, a square root, so radical 7 is a symbol for the number 2.645751311. Much like pi is a symbol for the number 3.14, yada, 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 right? Okay? But a radical is a symbol for what number I multiply by itself 2 times to get the 7 underneath the radical. Does that make sense? So when we take things like perfect squares, when that's a 4, well, what number do I multiply by itself 2 times to get 4? 2. And that, in this case, that's a rational number. It's not irrational anymore. If I think about like 16, well, number 4 multiplied by itself 2 times will give me 16. Does that kind of make sense? Okay. So when we take square roots, that's what we're doing. So if I were to come across a problem that was maybe we had 5x squared is equal to, we said 80 times 16. Let's say we had 80 times, or I guess it was 9, right? 80 times 9. Let's say this 80 was actually just 40. I can still divide by 5. So that's going to give me x squared is equal to 8 times 9, right? I can still square root this the same way. So x would be the square root of 8 and times the square root of 9. Well, what's the square root of 9? 3, okay? Now, I don't know what the square root of 8 is yet. 8 is not a perfect square like 9 was, okay? But what we can do, we can simplify this. And basically, when we simplify a radical, we're looking for the greatest perfect square that will divide 8 evenly, okay? And that 8 I'm going to call it's called a radicand. R-A-D-I-C-A-N-D, radicand, okay? When we simplify a radical, okay, we are looking for the perfect square, the largest perfect square that divides the radicand even, or evenly. Meaning that the smallest result I'm looking for here would be a perfect square that divides 8, so I get a result of 2, okay? Or I get a result of 3 or 4 or 5. That would be dividing something evenly. Does that make sense? Okay? So the only way that I can divide 8 by a number so it divides evenly is that if I divide by something that is equal to or greater than half of 8. Does that make sense? Okay, only way I'm going to get a quotient of 2 or greater is to divide 8 by 4 or something bigger than 4. Okay? Or sorry, smaller than 4. If I divide it by something bigger than 4, it's going to give me a number that is between 0 and 2. Does that make sense? Okay. So what we do is say, okay, well, if I take that, if I'm looking for a perfect square that divides 8, what I do is I look at 8 and I cut it in half. If I cut 8 in half, what do I get? 4. Now what I'm going to do is I'm going to run through the perfect squares that are smaller than or equal to 4 and see if they divide 8 evenly. So what are the perfect squares that are smaller than or equal to 4? 1 and 4, right? Okay. 1 obviously it's trivial, it's always going to divide it, but 4 divides 8, correct? So radical 8, what we can say is that radical 8 can be rewritten as radical 4 times radical 2. What's radical 4 the same as? What's the square root of 4 the same as? 2. So when I have 3 radical 8, it's actually the same thing as 3 times 2 radical 2, which is 6 radical 2. That's the simplified version. Okay? So when we're trying to simplify radicals, that's the idea, is that we're trying to find the number, the largest perfect square that divides the radicand. Okay? Sometimes there are values that do that, and sometimes there's not. Like if I take, like let's just say 15. Okay? If I want to take the square root of 15, well, the largest perfect square less than half of 15 would be 4 again, right? Half of 15, 7.5. 4 does not divide 15. So what that tells me is that 15 is fully simplified. Okay? There are other approaches. Have you guys ever seen this where you take like 8 and break it down to 2 and 4, and then 2 and 2, and you circle the 2s. There's a group of 2, and that comes out in front. And because that 2 didn't have a partner, it stays underneath. You ever seen anything like that? So you guys have done absolutely zero work with radicals. You did something with the tree before? Okay. What's going to happen? So I'm just trying to kind of gauge where we're at, because as we move into chapter 8 and beyond, this is going to be commonplace, okay, in our calculations. So trying to decide maybe we need some review on that before we get to that. Looking at question 18. So again, I'm just going to label things. So I'm going to label this as A, B, C, D, and E. It says for the pair of similar triangles shown to the right, find the value of x. So we know they're similar. Okay. If we know that is, so in both these triangles, angle A is going to exist, right? So it's got to be, in the name, it's got to be the same. If these two things are similar, okay, if they're similar, that means that that angle right there and that angle right there have to be congruent. Does that make sense? So I go A to B, and this one I should go A to D. Then I'll finish at C, finish at E. So that's my similarity. So I'm going to say AB compared to AD should be the same as BC compared to DE, should be the same as AC compared to AE. Now we know AB is 14, so use this first ratio and write it up here, 14 over AD. Now AD, what do I call AD? It's got to be x plus 14, right? How does that compare to BC? Well, BC is x plus 2. And that should compare to DE, which is x plus 18. Is that okay with how we compare them? Once we have that, then we're just going to cross multiply. So I get 14x. So I'm multiplying these two. So 14 times 18, 252. Equals then, now I'm going to cross multiply these two. So I get x squared. You have 14x and a 2x, so that's 16x total. So I'm foiling this, right? And 14 times 2 will give me 28. So now this is a situation that contrasts from the last problem, because the last problem, we could just take square roots right away when we had x squared, right? But now we've got x to the first. So that throws a wrench into the square root process. So we can't do that. Okay, so we're going to try to get everything equal to 0 here. So I'm going to set my x squared going to be on the right. Let's move this over through subtraction. So it'll be 16x minus 14x will give me positive 2x. And I'll subtract 252 over from 28. So that gives me 224, negative 224. Okay. Now, I think I've shown you this in the past, but a couple different ways we can address this. My thought is, right off the bat, do we know two numbers that multiply together give me 224 and have to give me 2? Is that something that comes to your mind right away? Or would you have to sit there and hash things out? Maybe take a calculator, take 224 and start dividing by things, right? We'll give you a good starting point, okay? Because this number is small. Because that number is small, okay? Basically what it tells me is that after we do this first step in this process is that I have to kind of look 2 units away from the value that I'm going to choose, or 2 iterations of the process that we're going to do. Basically what I'm going to do, so when I say small, I mean that could be, 20 could be small. It just depends on how big this number is, okay? But what I'm going to do is I'm going to take 224, and we'll take the square root of it. So we go second square root 224. Because that would be, say, so if I use like 14.97 and 14.97, so I go x minus 14.97 and x minus 4, or x plus 14.97, that would give me O and I's for my foiling technique that would make that 2x go to a 0x. Does that make sense? Okay. So in order to go from a 0x to a 2x, that number needs to change a little bit. So what I'm going to do is I'm going to take 224 and I'm going to divide it by an integer that is close to 14. Okay? Or 14.9. So you can either round up or round down. You'll never go wrong. But if I go divided by 15, it doesn't work. It gives me, because I'm looking for integer results when I divide the 224. So 224 and 15, not going to work. So what I do then is I go to 224 and I divide by the next integer. So I went to 15, so I can divide by 16. And it gives me 14. Or 16 and 14, 2 units apart. So there's your factor. X plus 16, x minus 14. Does that make sense? Okay. Now, if you were a person who said, well, you went to 15. What if I went down? What if I went 224? 224 and divided by, instead of 14.9 rounded up to 15, I round it down to 14. Well, does it give you 16 as a quotient then? And it gets you right to your answer in one step. Okay. But regardless, that is I think, an efficient way of figuring out what two factors to use. And then that's best used when that number is small. So if that was like a 5 or a 6 or 7, I could still do this, but I'm going to have to basically try integers that are ultimately 7 units apart. Okay. So it gives me x minus 14, x plus 16. So if those are going to be equal to 0, so this one, x minus 14 equals 0, x plus 16 equals 0. That's going to lead to x to being 14 and x being negative 16. Okay. Now, can x be negative 16? If I plug in negative 16 to those spots, does that provide a problem in some of those spots, or at least one of those spots? Yeah. So negative 16 cannot be an answer. 14 is my only answer. Okay. That's one way, and that technique for finding your factors will work. Using the TIA 384, but it'll also work using any other calculator that you might have. Let's see real quick. Let me give you an example here. Let's go X. All right, so an example, let's say we've got just purely the factoring portion of this. Let's say we had the quadratic that said x squared plus 5x minus 1886 equals 0. Does anybody want to sit and take 1886 divided by 2, 1886 divided by 3, 1886 divided by 4, and seeing what all your factors are? Nobody wants to do that, okay? Some of you might say, well, I know I got to jump, like divided by 2, divided by 3 ain't going to work, so jump somewhere in the middle. Maybe I start dividing by 20 or something like that. But that's still a trial and error, and you might be a lot less efficient than what is required of us, okay? So what I'm going to do, because, again, that number is not very big, right? That 5 is pretty small. So that tells me that my values that I'm choosing here in a moment are going to be pretty close to one another. So I'm going to take 1886. I'll take second square root 1886. And I get 43.4. Okay, so what I'm going to do is I'm going to take 1886 and we'll start dividing it by numbers that are integers that are close to 43. And I can go either up or down. So I'll just go down to 43 and it doesn't work. So I go 1886 and I'll try the next one. I'll keep going down. So 42 doesn't work. 1886 divided by 41 doesn't work. So we're looking for, so 3 iterations of division there produced our 2 factors, 41 and 46. So it'd be x minus 41, x plus 46, and we've got it factored. Does that make sense? If you like to use, if you have a TI-83, does anybody have this calculator that they use on a regular basis? Nobody? So I won't demonstrate then how we do that. What do we have to do here? Yeah, I have to find the distances. Okay, you guys remember, we're not going to do this in its entirety, but you guys remember how to find the distance from the distance formula?
Isn't it like y1 minus 1, 2, x2 plus 1?
All right, so we're going to subtract. It doesn't matter the order, x2, x1, x1, x2, or if you do your y's or x's first. But basically what you're going to do is underneath your radical, you need to subtract your x's and square it, and then add to it, subtract your y's and square it. And because you're squaring, that's why the order doesn't matter, because if you get a positive and square it, it's going to turn into positive. But if you get a negative and square it, it's still going to turn into positive. And because addition is commutative underneath the radical, it doesn't matter if you do your x's first or if you do your y's first. Okay? But what you're going to do, okay, is find these distances for AB, AC, and BC. Okay? And then once you have that, it's going to walk you through and ask you for dimensions for R, S, and T for that triangle. And then you're going to divide them and see if side, side, side holds. Do you think that's a good enough explanation, or do you guys want to go in more detail with this question and actually do it? You want to do it?
Yes.
If we go, so finding AB, so you're going to subtract your x's for A and B, so it gives you 2. You'll square that, gives you 4. Add to it the same thing for your y's, so 4 minus 0 is 4 squared will give me 16. So it's going to give me radical 20, okay? So AB is radical 20. Now if I type it, and I'm going to do this, I type in radical 20, it's going to tell me no. Okay, it's going to tell me I'm wrong. Okay, so we've got to do something with this radical. We've got to simplify that, okay? Let's find AC real quick. So A to C, I subtract my x's, gives me 4, square that, gives me 16. Take my y's, subtract those, square it, gives me 4. So again, I get another radical 20. So that right there tells me that this triangle is isosceles, right? 2 distances that are the same. And then let's find BC. So BC 4 minus 2, so the x is 4 minus 2 gives me 2, squared is 4. And then subtract my y's, 4 minus 2 again is 2, squared is 4. So I get that, which is radical 8. Okay, so if I were to type these in, and I think this is a lot of times where people get themselves in trouble, is that they don't read the directions. They type in 20. Oh, don't want that one. Radical 20. Radical 8. Done everything right so far. Check answer. Tells them they're wrong. Okay. The feedback here is not all that great. Tells me what I need to do to get those answers, but the 20, is there a perfect square that divides 20? Well, we've only got to check things that are less than half of 20, so only got to check perfect squares that are less than 10. Are there any perfect squares less than 10 that divide 20? 4. Okay, so 20 is the same thing as radical 4 times radical 5. So when I take 20 divided by 4, I get that 5, right? So what's the square root of 4? 2. Okay, now if you're of the train of thought or the school of thought that says, I'm going to take my 20, rewrite that as 2 and 10, and take my 10 and write it as 2 and 5, group of 2's, so that comes out in front. And the 5 doesn't have a group, so it stays underneath. Regardless, it becomes 2 radical 5. 8, same idea. What's the perfect square that divides 8? 4, right? So you get radical 4 times radical 2, so it's 2 radical 2. So now we're going to type in two radical 5 here. 2 radical 5, 2 radical 2, check our answer, and we're good. Okay, so that's the only reason I missed it was because I didn't simplify, right? Did all the geometry right, but the algebra was pretty bad. Now they want us to do the same thing with RS, RT, and ST. Okay, so R to S, so let me clear this out. R to S, so subtract the x's, so it'd be 1. Square that, still be 1. Subtract the y's, so 5 minus 3 is 2. Square that is 4, so I get radical 5. So radical 5 will go there for RS. Do the same thing for R to T. Okay, so I'm going to take the x's, subtract those, so it gives me 2. I'll square that, gives me 4. Then subtract the y's, gives me 1. Square that, gives me 1. So radical 5 will go in for RT as well. And then ST will be those two. So subtract the x's, so negative 2 minus negative 1 turns into negative 1 squared would be 1. Plus then subtract the y's. So 5 minus 4 is 1. Square that, I get 1. So that's radical 2. So right here, and this is why they wanted you to simplify it, here I get radical 5, here I get radical 5, here I get radical 2. Check those answers, good to go. What's the relationship between these two things right here? How do those divide? If I have 2 radical 5 over radical 5, that's just 2, right? 2 radical 5 over 1 radical 5 essentially, but the radical 5s cancel each other out, just leaving me 2 over 1. Is that the same thing there? Is it the same thing there? So they all reduce to 2. And we're done. Okay, well, we could say that, so these would be similar by the side-side-side theorem. Okay, and we're done with that proof. But now, here's why they want us to simplify. We found that these numbers right here were radical 20 and radical 8, right? So radical 20, radical 20, radical 8. Down here, we found radical 5, radical 2. Do those two look like they are in the same, obviously they're the same ratio of these two, right? They're identical, so they have to be in the same ratio. But do those two compared to one another look the same as radical 8 compared to radical 2 look? It's impossible to see if they're unsimplified irrational numbers or radicals like this. It's impossible to do that comparison until they're simplified. Okay, so that's why they ask you to do that. That's why we need to have that skill. I'm going to leave that assignment open until Friday. Okay, so give you quite a bit more time to work on that. But I'm also going to give you another assignment as well. I'm going to give you a worksheet. Okay, the worksheet is going to be, we're going to talk about some of these questions tomorrow in class. If not tomorrow, definitely Friday. There are some questions on here that are pretty cumbersome for some people. Okay, I'm not going to say that they're, I would especially pay attention to question 14. 14 is a difficult question. Okay, but they're all targeting essentially angle. Okay. But they're going to allow us to see some applications. We saw some story problems here of how we could actually use the math that we've been talking about in the last couple of weeks, last couple of days, in real life. Okay, so I'm going to post this on Schoology right now, and that's where you can grab it. You can start working on it. There will be a math Excel that attaches to this, so it's not posted yet, but there will be. Within an hour or so. I'll make it due on Monday. It's lengthy. There's some things that we're gonna probably want to talk about tomorrow to help do some of those story problems. So let's put Monday on that. Yes. Where did you go? Yes. Give me 1 second. Yes. My homework post, there it is. It disappeared on me. Google Drive. Schoology. That's gonna take a minute for me to get that posted. 39 and 20. 780. Okay, 2x squared. 16x, negative 6, so 10x. Negative 48. Okay, so here's the issue. When you divide by 2 here, you divide all these things by 2.
Oh, okay.
And then, so it'd be 390, x squared, 5x, and 24.
Okay.
And that would, should clean things up
So
here.
sitting there, I'm trying to do like the math and saying, I don't know if that one.
Yeah.
Can I go pull this up?
Yep. Answer.